Hi, this is Brian Kim. I'm going to share with you case number 151 in the Best Way to Do Cataract Surgery series. This is a 1 to 2 plus dense lens. It's a small pupil, medium pupil, and you're going to see double chop, cross chop mechanical fracturing and confident lens disassembly despite the smaller size pupil. Again, so this is a small to medium sized pupil, but I'm going to be able to illustrate how efficiently I'm able to disassemble this lens, especially this somewhat more soft lens, despite limited visibility because I'm confident in my technique. So I'm using a cotton tip to steady the eye and then using a corneal marker which will help me to center and size the rexus. Then I make my paracentesis incision first on the right side and then the left side, making sure I'm parallel to the iris plane, which creates a nice corneal shelf, which will allow me to achieve a self-sealing incision. This is intracameral lidocaine and then intracameral epinephrine. And this is some dispersive viscoelastic to coat the corneal endothelium and to flatten the anterior capsule. This is a triplanar corneal incision. I make a vertical groove, place the blade into the deep part of the groove, tunnel through the cornea, and then I enter. For the capsule rexus, I puncture in the center, pull down, grab the right side of the tear. I start to go around circumferentially. Finish off the rexus, burp some viscoelastic out. And this is the capsular fornix hydrodissection technique. I place a cannula underneath the rexus edge contra-incisionally, point the tip down, get a nice wave. In this case, you saw there's a giant bubble that goes underneath. The good news is the bubble doesn't cause any damage or posterior capsule rupture. This has happened a few times to me now. It does make for an interesting hydrodissection, but in this case, you can see the lens began to spin. Irrigate the surface of the eye. Lifting the incision with a chopper, going in with irrigation off to minimize Descemet's trauma. Removing the surface epinuclear material. So here it is in slow motion. I'm pronating my hand so that the tip of the chopper is pointed out away from me. It's flat and horizontal in position and parallel to the lens surface. I'm sliding it underneath the rexus edge, and then I supinate and start to turn so that the chopper is pointed more up and down, but it's actually, the tip of it is pointed towards me a little bit. I have the phaco tip rotated vertically subincisionally. I'm stabbing into the meat of the lens, and because this lens is soft, it is moving in the horizontal direction because I'm able to impale and stab into the meat of the lens material. I bring both instruments together. Look at the tip of the chopper. It's pointed towards me. It's not pointed down. For those of you who are scared, you can see that that's not going straight down. It's actually going to be more away from the posterior capsule that way. I pronate my hand again and I slide the chopper out underneath the rexus edge around the right heminucleus. I straighten it out, supinate it so it's more vertical, pull it centrally towards the phaco tip, and I'm able to fracture the right heminucleus in half. So now within seconds, I have 3 separate pieces performing the double chop and the cross chop maneuvers. use some high vacuum to lift that first quadrant up, which comes out quite easily here. And then I just crush the lens between the instruments. Again, these fairly soft lenses, and in this case in particular, the medium pupil, I don't really have to depend upon what I'm seeing. That's why when I'm doing the maneuvers, sometimes you can see there's a lot of lens material that's being liberated. But it doesn't really affect how I'm doing the case because I know where I am with my instruments. And so even though all this lens material is coming out, it might seem haphazard, it might seem a little confusing, but at the end of it, when I start grabbing for the piece with vacuum, you can see it pop right up. So because the lens is soft, I'm just using a lot of high vacuum to remove that first quadrant. Again, I pronate my hand, get underneath the rexus edge. Oh, I'm just turning that lens first. Perform another cross-chop maneuver around that second quadrant, lifting the piece up, crushing the lens between the instruments. And again, because the lens is soft, it's just kind of falling apart here. Crushing the lens again between the instruments. And then emulsifying the lens pieces. I'm going to turn the second heminucleus in front of me, placing the chopper around the lens piece, pulling it centrally towards the figure tip, and then crushing and bisecting that second heminucleus, grabbing that third quadrant and then crushing it between the instruments and then emulsifying the lens piece. With these soft lenses, again, really double chop and cross chop really shines because it's so easy to fracture the lens pieces in half because it's so soft. You can push through the epinucleus and even some of the outer part of the endonucleus because it's soft, and fracturing that central core is so easy with this maneuver. Crushing that last bit, but keeping that chopper deep to protect the posterior capsule, being very careful when I'm using the vacuum in between. I'm on and off and on and off. You can see what I'm doing there. I'm on and off and on and off on the vacuum. Again, trying to use as little vacuum as possible to protect that posterior capsule and keeping that chopper back. So there's a lens piece that's stuck underneath me, but I decide not to go after it with the chopper. I come out with the chopper and I'm pushing some dispersive viscoelastic, and I'm visco pushing that lens piece towards the center. And once I do that, I'm able to grab it with some vacuum with the phaco tip, switch back to the chopper, protect the posterior capsule with the chopper, and I'm done. So I take the chopper out, push BSS in, take the phaco tip out, go in with the INE handpiece, starting subincisionally removing the cortical material. Polishing underneath the rexus edge, removing the lens epithelial cells. Switch to cortex when I grab that big chunk of cortical material, and then switching back to polish mode. And doing that once again there. So switching, using foot pedal modulation and switching between settings is really very nice in this situation. So very careful, I'm going to polish and pulse into the subincisional capsule fornix. You can see there's some lens material that's being liberated here. I try to be careful in these situations when the rexus edge is beyond the pupil here when I'm pulsing. Pushing some cohesive viscoelastic to fill the bag, and then I'm going to start polishing under the rexus edge here on the left side and then the right. especially in these situations where you don't see the capsule as well. I'm fairly ginger when I do that maneuver. This is a single piece acrylic lens. It's going to go into the capsular bag. And as it unfolds, I switch to the INA handpiece. I go in with irrigation off, activate irrigation, making sure the haptics come off the optic, go underneath the lens, tilting it and rotating it 90 degrees clockwise, removing the viscoelastic from within the bag. Polishing underneath the rhexis edge, removing the lens epithelial cells, any cortical material that's been liberated. Switch to visco mode, removing the viscoelastic from the anterior chamber, and then I'll hydrate my incision. So again, this is a medium-sized pupil. I was able to perform double chop, cross chop mechanical fracturing techniques. This is a somewhat softer lens, 1 to 2 plus dense lens. You can see the CDE wasn't very high. And this is really a typical case, a routine case with regards to the density of the lenses, on the softer side. But, a lot of people struggle with soft lenses. They try to sculpt it, but then it kind of falls apart because once you sculpt a soft lens, when you try to separate the pieces, it just kind of cheese wires through. It's just kind of this jello substance. And because the diameter of the lens is bigger than the rhexis opening, people struggle to get it out. You can try to hold the lens with high vacuum, but then it falls apart. And so doing these maneuvers that basically are indirect maneuvers to try to, grab onto the lens and then break it up are really inefficient. And so by using mechanical fracturing techniques, by getting around the lens piece with your instruments, crushing, and just using crushing forces to disassemble the lens is really just so much more efficient, it's so much more direct, and it's so much more versatile. You can't really get yourself into trouble when you're doing it this way. You don't have to, try to grab, and then it's with vacuum, and then it just starts falling apart. And at some point, you're going to run out of real estate. You're not going to have anything else to grab. And then you're down to the posterior capsule and you're really in trouble because you're trying to grab the lens and right behind it is the posterior capsule. It's very dangerous. But using mechanical forces to get around the lens, hooking the lens piece around the capsular fornix, and utilizing the instruments to your advantage and using two hands together, it's really the easiest way, in my opinion, and the most direct way and safe way, because you're able to use the instruments to very carefully even get close to the posterior capsule and lift these lens pieces up, which is much more controlled than using the instruments and getting really close to the posterior capsule and applying high vacuum with a phaco tip. So I hope this was helpful to you, and I thank you for your attention.